Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? If you'd like to accept that challenge, pause the video and see what you can do. All right, this is a strange looking pattern. I think I'm going to try to find what's the same in every step. And let's see, I notice this row of 3 just stays the same. It's a row of 3 attached to the bottom. So I think that's constant from step to step. So if I'm going to predict what's in step 4, I think there'd be a row of 3 down here at the bottom. And then let's see. So this chunk in the middle, it looks like it's rectangular but growing. And so first is 1 by 3, 2 by 4, 3 by 5. So this should be a 4 by 6, I think. 4 by 6 rectangular chunk. Yeah, I think so. And then what's left is this. First it's 1, then it's 2, then it's 3. So I would say this is 4. Okay, let's add up everything we've got here. So 4 by 6 is 24, and 4 more is 28, and 3 more is 31. So I'm going to predict 31 for step 4. So kind of a complicated shape there. What kind of a pattern is this going to be? Looks like it's getting big pretty quickly, but let's look at the numbers and see if we get any hints from there. Maybe you know already. I'm going to list the step numbers and then the number of squares in each step. So in step 1, we have 7. In step 2, that's 8, 9, 10, 11, 12, 13. In step 3, there's 15 there, 16, 17, 18, 19, 20, 21. And we just predicted that in step 4, there'd be 31. So when we analyze these numbers, we take the differences between each step. So 13 minus 7, that's 6. 21 minus 13 is 8. And 31 minus 21 is 10. Aha, so we do not get a constant. So this is not a linear pattern. If you get a constant in the first set of differences, it's linear. If you don't, you can take the second set of differences. So 8 minus 6 is 2, 10 minus 8 is 2. That's what I suspected. If you get a constant in the difference of the differences, it's quadratic. So you've got an x squared happening somehow. But how exactly? Is it only 1x squared? What else is going on? I think we can gain some insight about a formula by just looking at these pieces. Like, for example, this 3 in every step, that should just be a plus 3 at the end of an equation. So I'm going to assemble this down here. There's my plus 3. And then this part up here, first it's 1, then it's 2, then it's 3. So that's just the step number. And we're going to represent the step number with x. So I'll add an x there, a plus x. And then the trickier bit is this chunk in the middle. And it's a rectangle, and we can write the formula for the area of a rectangle. That would give us the number of squares in that rectangle. First, it's 1 by 3, then 2 by 4, then 3 by 5. So one of the sides is the step number. So that'd be x. And the other side is 2 more than the step number. So I'd write that as x plus 2. So we've got x times x plus 2 plus x plus 3 from our visual insight here. So that's a little complicated. I bet if we kind of multiply things out and combine the like terms, it might look a little less complicated. I'm going to distribute this x here. So x times x is x squared, and 2x, plus 2x plus another x plus 3. If we combine these, we get 3x. So this is x squared plus 3x plus 3. So that, I think, is our equation. If we plug it into a couple of these up here, let's plug it into step 2. You'd put in 2 for x, you'd get 2 squared plus 3 times 2 plus 3. And that should be the number of, this should add up to 13, the number of squares in that step. So that's 4 plus 6 plus 3. Yeah, that works. What about in step 3? That'd be 3 squared plus 3 times 3 plus 3. A lot of 3's there. So 9 plus 9 is 18, plus 3 is 21. Yeah, so this equation seems to be working out. If we've got an equation that we're confident in, we can just plug in 43 for x to find how many in step 43. So that'd be 43 squared plus 3 times 43 plus 3. And let's see, 43 squared is 1849. And then 3 times 43 is 129. And plus 3 more. All right, what is that going to be? So we get a 1 there and an 8 here. And I think it's 1,981. Double check my math on that one, but I think that's right. So how did that go for you? This was a tough one, I think. Did you get 31 for step 4? Did you come up with any kind of an equation? Let me know. Thanks, everybody.